Hello student, let us see the Caster-Kellner cell method for the preparation of sodium hydroxide student. This Caster-Kellner cell method is also known as student, that is mercury cathode cell. This is, if you see student, this is also known as mercury cathode cell, right student. In this student, in this cell there is two compartment is there. First one is outer compartment. Outer compartment cathode is mercury and anode is graphite, where you are taking electrolyte by in solution NaCl student, which ionize to give Na plus and Cl minus. Now student, what is happening at the anode? We know that is oxidation reaction, and at the cathode reduction reaction is taking place. So 2Cl minus it will convert into Cl2, and here is the at the cathode student mercury is there, it is giving Na2Hg. Now in the middle compartment with student, cathode is iron rod, anode is mercury, that is become okay. Now electrolyte you are taking NaOH student. So what is happening at induced anode oxidation, Na2Hg 2 electron is oxidized to Na2 plus and Hg. At cathode the reduction is taking place student with the water molecule, it will give that is NaOH and H2. The amalgam is treated with the water to get NaOH. So NaHg react with water, it is giving 2 NaOH plus 2 Hg plus H2. So this is all about the reaction of the what student preparation of the sodium hydroxide from the Caster-Kellner cell, right student. Now student, what we can do here, we can go little more deeper for the Caster-Kellner cell student, and then try to find out the correct answers. So Caster-Kellner cell or mercury cathode cell, it consists of the large rectangular tank divided into 3 compartments by the slate partitions which do not touch the bottom of the tank. Means here whatever is there student, they are not touching the bottom of the tank. This is the partition which is not touching the bottom of the tank. The slate partition are suspended in the mercury placed at the bottom of the tank. Thus mercury in one compartment can flow into other, but the solution present in any of the compartment cannot flow into the other. Let us have a look over it student. Brine is placed in the outer 2 compartments, where central compartment contain dilute NaOH solution. On passing current, electrolysis takes place in outer and central compartment as given below. Outer compartment, what is there student? NaCl, it is giving Na plus Cl minus, H2O, H plus OH minus. So Na plus H plus ion migrate towards mercury cathode, whereas Cl and OH minus migrate towards graphite anode. So at anode, what is happening? Oxidation of chloride ion, because the discharge potential of Cl ion is lower than that of the OH minus ion. Therefore what is happening? Cl ion give up its electron in preference to OH ion, and Cl2 gas is liberated at anode, while OH ion remains in the solution. So at anode, what is Na plus plus electron NaHg, sodium amalgam. This sodium amalgam passes into central compartment due to the rocking motion given to the cell by the eccentric wheel. So this central compartment NaOH is ionizing Na plus OH minus. So H2O is also there. So what they will do student, they will combine like NaOH being strong electrolyte undergoes complete dissociation, whereas H2O being weak electrolyte partially ionized. So H and Na ions migrate towards the cathode, where OH ion migrate towards anode. So anode, if you talk about HOH, and this is the NaOH is forming at anode. OH minus ion migrate towards anode, combined with sodium amalgam to form the NaOH. At cathode, hydrogen is getting released. Because discharge potential of H plus is lower than that of the Na plus ion, H plus ion are thus discharged as cathode. H2 is liberated. Now student, you can see as H plus ion are continuously discharged at the cathode, the equilibrium 4.8 shifts toward the right, thereby producing the more OH minus ion. The OH minus ion thus produced react with the sodium amalgam, forming more and more NaOH. When the solution NaOH is sufficiently concentrated 20%, it is drawn out, evaporated, fused and cast into sticks. So this is all about the casted Kellner cell, student, where what is happening, there is a two compartment are there, student. In one compartment, if you talk about, the mercury is there, and that is the at the anode. Okay, anode, there is a oxidation reaction where Cl2 is converted, Cl and 2 is converting into the 2Cl minus, and at the cathode, that is they are getting reduced. How electrolyte we are taking the brine solution, students, so it is see how it is ionizing, and that anode what is happening, you can check out, 2HCl minus converting into Cl2, and then water is here, so this is forming, that is NaHg, and finally it will form the NaOH, student. Thank you so much for watching, dear students.